Welcome to the ASCENT Carbon Program. This presentation outlines how digital MRV, enhanced methodologies, and integrated systems are enabling scalable, transparent, and high-integrity carbon credit generation from projects undertaken as part of ASCENT Energy Access Program. Let's start with an overview of the ASCENT program. ASCENT is designed to deliver new electricity connections to over 100 million households across Africa through both grid and distributed renewable energy solutions. At the core of the program is digitization, enabling faster, more efficient, and transparent planning, implementation, monitoring, reporting, and verification of energy access interventions. ASCENT also aims to generate high-integrity carbon credits, helping channel carbon finance directly into project implementation. To enable this, the program incorporates key elements, including the enhancement of existing methodologies with digital MRV protocols, the development of an institutional framework to embed DMRV within the program standard, and integration with national registries to support issuance under Article 6.2. Now let's look at the key project activities under the ASCENT program. The program focuses on scaling up distributed renewable energy and clean cooking solutions across Africa. These include solar home systems for rural households and community centers, as well as renewable mini-grids that provide localized power to underserved communities. It also supports the expansion of electricity access through new grid connections and promotes the productive use of renewable energy in areas such as agriculture, healthcare, education, and cold storage. Overall, ASCENT aims to deliver clean energy access to around 100 million people across East and Southern Africa. In addition, the program targets energy access for approximately 50,000 health and educational facilities, clean cooking solutions for millions of households, and improved energy access for over 10 million farmers and rural enterprises. Let's now look at the components of the digital MRV ecosystem. At the project site, the DMRV system captures data through monitoring devices and a local data acquisition system. This data is then transmitted to a centralized data platform where it is securely stored and processed. Within this system, a carbon engine applies automated quality checks using AI and machine learning, while also converting raw data into greenhouse gas emission reduction estimates. The validated data is stored in a central databank and used to generate monitoring reports based on timelines defined by the project owner. These reports are then assessed in line with GCC standard requirements, leading to the issuance of carbon credits. Each component within this ecosystem is governed by defined acceptance criteria, ensuring accuracy, transparency, and integrity throughout the process. Let's now understand how the methodology has been updated to support digital MRV. A key component of the ASCENT Carbon program has been the enhancement of existing distributed renewable energy and clean cooking methodologies to integrate DMRV requirements. These updates ensure that the methodology reflects real-world monitoring practices and data availability on the ground. The approach focuses on simplifying workflows to enable full digitization, while also incorporating multiple data pathways, including the use of measurement proxies where primary data may not be available. It also accounts for practical implementation models, such as pay-go model, which are widely used across energy access projects. In addition, the methodology incorporates key carbon market requirements, including robust baseline setting and the treatment of suppressed demand, to ensure the generation of high-integrity carbon credits. This schematic illustrates how different project types, data points, and monitoring pathways are structured within the updated methodology. Building on this, the schematic shows how the methodology operates in practice. It outlines the different pathways used to determine energy consumption and calculate emission reductions, depending on the availability of data. For projects with metered systems, energy use is continuously monitored and directly used for credit calculations. Where such data is not available, the methodology applies alternative approaches, including surveys, standardized parameters, and conservative assumptions. These pathways are supported by built-in checks and adjustment mechanisms, ensuring that emission reduction estimates remain robust and avoid overcrediting. This structured approach allows the methodology to adapt to different project conditions while maintaining consistency and integrity in credit generation. What truly sets the DMRV approach apart is the shift from conventional processes to a fully digital, data-driven system. In traditional carbon project cycles, verification is often time-consuming, dependent on manual audits, and subject to uncertainties. With DMRV, data is captured, validated, and processed continuously, enabling near real-time issuance of carbon credits. The system reduces reliance on manual intervention, automates GHG calculations, and significantly improves efficiency in due diligence and verification. It also enhances transparency, with data accessible to stakeholders and traceable back to individual mitigation activities. This not only builds confidence in the system, but also ensures that credit issuance is more accurate, timely, and aligned with market needs. Let's walk through the ASCENT registration process. At the center of this workflow is the Energy Access Program portal, which serves as the core platform for managing project registration. Project proponents begin by onboarding onto the system, followed by submission of the required documentation, including authorization and program design details. The DMRV layer integrates directly with the system, capturing and processing data from mitigation activities and feeding it into the registration workflow. This data is then validated and used to support the preparation and submission of the program design document. The process includes independent validation, followed by registration under the ASCENT standard. Throughout this workflow, the updated methodology and regulatory framework provide the necessary templates, requirements, and guidance. Governance oversight ensures that each step is aligned with program standards, and once registered, project information is made publicly accessible. Finally, let's look at the ASCENT issuance process. At the core of the program is the ability to deliver high-integrity carbon credits on a near real-time basis, enabled by digital MRV. Once a mitigation activity is implemented, it is onboarded onto the system through a digital interface. Upon approval, the activity is integrated into the system, and data ingestion begins through automated interfaces. Data from the mitigation activity is continuously captured through the DMRV system and passes through multiple quality control layers before being processed within the carbon engine. A parallel copy of the data is also securely stored within the standards repository. Based on this validated data, greenhouse gas emission reduction claims are automatically generated in line with the applicable methodology and program tools. In parallel, non-GHG claims are handled through a structured review process supported by documentation and validation inputs. Once both GHG and non-GHG claims are reviewed and approved, the system initiates the issuance process. For authorized credits, host country approval is incorporated, enabling issuance under Article 6.2 and CORSIA frameworks in line with the host country letter of authorization. Overall, this integrated digital workflow enables faster processing, improved transparency, and high-integrity credit issuance. Ensuring data integrity is central to the digital MRV approach, with validation built across multiple layers. At the first level, the DMRV system itself is certified by an independent third party against defined standards, ensuring that data is captured accurately, securely, and without tampering. As part of QA-QC checks, the data undergoes a series of automated checks, including trend analysis, comparison with expected generation potential, and validation against historical data. These checks help identify anomalies, duplication, or inconsistencies in the data. At the next level, data is validated against external references. This includes comparison with secondary datasets such as weather data, as well as predictive analysis using digital twins based on project parameters. Data trends are also benchmarked against similar mitigation activities in the same region to ensure consistency under comparable conditions. In addition, AI-driven systems help detect risks of double claiming by cross-referencing project locations and activities across different programs and standards. Together, these layers ensure that data is accurate, traceable, and fully aligned with high-integrity carbon market requirements. ASCENT Program is creating a new pathway in carbon market by way of inclusion of a DMRV protocol into the program standard and creating a workflow which uses an end-to-end digital platform. The credits would be generated on a near real time with minimum human intervention, but still having full oversight of the standard and its governance system into the credit generation process. The system not only helps in generating GHG claims, but also audits and appends non-GHG attributes to these carbon credits, thus ensuring that they not only represent actual reduction in GHG emissions, but also ensure no social or environmental harm and contribute to SDG priorities of the host countries.